work for you better. All right, so chemical equations. This is the fun side of chemistry. Just a few notes on terminology. So the reactants, right here, the reactants, those are the chemicals initially combined. So we got them here and here. So where are they? They're on the left. Then we have products. And these are the ones that are formed, right? So they are this guy. And you can have more than one product. You can have a single product. This one has to have just one. So this is going to be the right of the arrow. So reactants goes on the left, products go on the right. The number of each reactant or product is shown using a coefficient. Now you'll see this word come up again from me. So coefficient is this number. It's the assumed one in front of him and the assumed one in front of him. So like most of chemistry, we don't write the one, we assume it. That's called the coefficient. It's the big number in front. So, and in blank is used to indicate that the reaction has occurred. And this is just really simple stuff here, an arrow. So that means it's occurred. And when you get it, like if you try and read it out loud, you're going to say either reproduce, like the way I would say this is A as a gas plus 2B as a solid yields AB2 as a liquid. Or I could also say produces or forms, those kinds of words. And then you're going to use a plus sign. That's what you place between the different products and the reactants. And then right here, we have this thing about states of matter. All right, so the states of matter, that's a symbol that's placed behind, so it's behind each of the reaction components. And so this is products or reactants. And here's the list of your options: solid, gas, liquid, or this thing called aqueous. That means dissolved in water. And we're going to talk a lot about water in this chapter and dissolving things in water. So that, and that. And the theory of mass applies so that the number of the atoms on the left should be the same as on the right. They're just combined differently. So notice on the left, there's one A right there, and there's two B's, and then on the right, I have a total of one A and two B's. I don't lose any atoms. You can't just make atoms disappear. So that all has to add up the same. So we've got the conservation, that's actually matter, and then mass is just saying that if I have one A and I know what he weighs, and I have two B's and I know what he weighs, this side of the reaction should weigh the same as this side of the reaction. So if, for example, I have, I'll go back through here. If I have 1 gram of A, and if I have 0.5 grams total of B, that's the total again, then I should have 1.5 total grams of AB2. Now, of course, in real life, you lose things. The reaction doesn't go completely. There's a lot of reasons why in real life you don't get a perfect answer, but that's the theory behind it.